Okay, so we are given the formula for the viscosity of a liquid, ether here. So obviously this is a product of terms, so we are going to add up the fractional uncertainties. So delta ether over ether is equals to, do we include delta K over K? No, because K is a constant. So there's no uncertainty associated with this constant here. It's just 93.7. So delta K over K will also be 0. That's why we don't include it. There's a R here, of course we must include delta R over R, but there's a power of 2 here. So this fractional uncertainties is doubled. And of course we include the delta V over V. Delta V over V. So just put in all the numbers from here, just substitute all the numbers and you get the fractional uncertainty. It turns out to be 5.487%. This is the fractional uncertainty. To obtain the absolute uncertainty, of course, we take the percentage times the the calculated value of 9.93. I suppose if you put in 0.83 and 0.065 into the formula, you calculate it to be 9.93. But the question sort of already told us is 9.93. So we just use that number. And turns out the uncertainty is 0.5449. But you know, by convention, we always write the uncertainty to only 1 SF. So we round off 0.5449 to 1 SF. I suppose in this case we are being very conservative. So instead of rounding off, which means we usually round it down to 0.5, in this question we chose to be more conservative. So we actually round it up to 0.6. So that's a 1 SF number for the uncertainty. It's also the convention to write the calculated value to have the same precision as the uncertainty. That means these two numbers should have the same number of decimal places. So since this one is written to the nearest 0.1 decimal place, we also round this number to the nearest 0.1 decimal place. So that's 9.9 here. Alright, this is quite a standard question. See you, ta-ta!